Okay, one of the things that we want to make sure that we understand is finding domains and ranges of the toolkit functions. So we're going to return to our set of toolkit functions to determine the domain and range of each. So in this first graph, this is the constant function f of x, which is equal to c. The domain consists of all real numbers, and there are no restrictions on the input. So the domain continues from the left arrow to the right arrow. So it's going from negative infinity to positive infinity. So that's our domain. So there's no restrictions on the input. Now the only output value is the constant c. So that means that this is the only number that's listed on the graph that's passing through the y-axis. So the range is a set of all the values that just include c. So we have bracket c, comma c, and that contains this single element. So the interval notation is written as c, comma c with brackets at both ends. So the interval that both begins and ends with c. Next we have the identity function, f of x, which is equal to x. So there's no restrictions on x, and both domain and range are the set of all real numbers. Because if we take a look at all the values that correspond to the x-axis, it has an arrow on both ends. So it's going to go from negative infinity to positive infinity. And likewise, for the range, it's going to start at negative infinity and go all the way up to positive infinity. So we can see that the domain and range are the same for the identity function. Now for the absolute value function, we have f of x, which is equal to the absolute value of x. So there is no restriction on x. Well, let's take a look here. If we take a look at the x-axis, it's going from negative infinity to positive infinity, which means we have all values of x that are going to correspond to this graph. Now, when we take a look at the range, it doesn't go below 0. So we're starting at 0, and it's going all the way up to positive infinity. So again, the domain goes from negative infinity to positive infinity, and the range includes the 0 and going all the way up to infinity. Now for the quadratic function, we can see that f of x is going to equal x squared. So the domain is all real numbers, since the horizontal extent of the graph is the whole real number line. So again, we're going to go from negative infinity to positive infinity here. And so that's going to give us our domain. And then if we take a look at the range, okay, again, it's similar to the absolute value function. We're starting at 0, and then we're going all the way up to positive infinity. So again, the domain are all real numbers, and the range starts at bracket 0 going to infinity. When we look at the cubic function, f of x is equal to x cubed, the domain is all real numbers. So that's going from negative infinity to positive infinity. And likewise, we're going from negative infinity to positive infinity for the range. So the same applies to the vertical extent of the graph, so the domain and range include all real numbers. Now let's take a look at the reciprocal function. Okay, when we look at the reciprocal function, when we look at the domain, okay, we're going from negative infinity, and then it's going to stop here at 0. So that means we're going from negative infinity to 0, and that means we're not including 0 because it doesn't cross that. And then we're going to start up again at 0 and then go to the right. So that means we have negative infinity to 0, and then a union symbol, and then 0 to infinity. Likewise, we're starting from negative infinity to 0 for our range. And then we're going to start back up again at 0 and then go up to positive infinity. So again, our range is going to go from negative infinity to 0, union, and then 0 to infinity. So when we're dealing with the reciprocal function, the reason why is because we cannot divide by 0. So we must exclude 0 from the domain. So that's why 0 is not included in a domain. Further, 1 divided by any value can never be 0, so the range also will not include 0. So in set builder notation, we could also write x such that x is not equal to 0. So the set of all real numbers that are not 0. So we want to make sure we can analyze what's happening here. Next we have the reciprocal squared function. That says f of x is equal to 1 over x squared, and we cannot divide by 0, so we must exclude 0 from the domain. So we're going to go from negative infinity to 0, and then exclude 0, and then go from 0 to infinity. So there is our domain. So there is also no x that can give an output of 0, so 0 is excluded from the range as well. Note that the output of this function is always positive due to the square in the denominator, so the range includes only positive numbers. So again, pay close attention to the range here. We have parentheses 0 going all the way to positive infinity. Then we have the square root function, f of x, which is equal to the square root of x. We cannot take the square root of a negative real number, so the domain has to be 0 or greater. So starting at 0, we can include 0, going all the way to positive infinity. And now the range also excludes negative numbers because the square root of a positive number x is defined to be positive, even though the square of a negative number, negative square root of x, also gives us x. So that means we're including 0 and going all the way up to positive infinity. And then we have our cube root function, which is the cube root of x. Now the cube root of x, the domain and range include all real numbers. Note that there is no problem taking a cube root or any odd root integer of a negative number, and the resulting output is negative. So we can see that the domain is all real numbers, and we can see that the range is going to be also all real numbers. So we want to make sure that you identify what's happening with each of these toolkit functions according to its domain and range.